Welcome to Mathenatic. We are busy revising content for paper 1, and in this video we have a exam type question on a quadratic number pattern, and this question has two parts. The information is a quadratic sequence has the following properties. The second difference is 10, the first two terms are equal, and term 1 plus term 2 plus term 3 is equal to 28. Show that the general term is Tn equal to 5n squared minus 15n plus 16. What I would like to do first is establish this information where it says the first two terms are equal. So instead of working with term 1 and term 2, I'll set them both equal to x. Then I have a number pattern that looks like x and then term 3. They tell us that the second difference is 10. So the difference between x and x is 0. Then t3 minus x is t3 minus x. Then the difference between t3 minus x and 0 is 10. So can you see I am creating the second difference in terms of x and t3 in order to find my second difference. So the equation of this pattern is Tn is equals to an squared plus bn plus c. And we know that the second differences is equal to 2a, so we can solve for a. And we know that 3a plus b is equal to 0, so we can solve for b. To solve for a, I set 2a equals to 10, and therefore a is equals to 5. And then 3a plus b is equal to 0. And then substituting a into that equation allows me to solve b, so b is negative 15. So from our question, we already have the a value as 5 and the b value as negative 15. Now what we need to do is find the plus 16. So this part of the solution, to find the plus 16, means that we would need to use a simultaneous equation. Firstly, we can set up an equation with the first three terms. So they told us that term 1 plus 2 plus 3 is equal to 28. And we know that term 1 is x and term 2 is x. So x plus term 3 is equal to 28. And then secondly, from the second differences, we know that t3 minus x is equal to 10. So can you see we have two equations now that are both linear equations. In both of those equations, we have the same variables. We have x's and t3. So if I manipulate those equations, in the first one, I can isolate t3 by moving the two x's to the right-hand side. So term 3 is equals to 28 minus 2x. And in the second equation, I can isolate t3 by moving the x to the right-hand side. So t3 is equals to 10 plus x. But can you see that term 3 and term 3 is supposed to be the same value because it represents one position on our number line. So that means that 28 minus 2x would be equals to 10 plus x. And if I put all the x's on the right-hand side and all the numbers on the left-hand side, I have 18 is equal to 3x. And when I divide by 3 on both sides, I have x is equal to 6. So that means in our number pattern, we have 6 and then term 3. And what we know is that 6 is equals to a plus b plus c. We have the a value and we have the b value. So a plus b plus c would be equal to 6. The a value is 5. The b value is minus 15. And then moving these values to the right-hand side allows me to find c of 16. Therefore, we can conclude that Tn is equals to 5n squared minus 15n plus 16. The second equation says, is 216 a term in the sequence? So in the previous question, we have established what the general term is. Now what we can do is replace Tn with 216 and try and solve for n. If we can find the value of n, then we can establish that that term is in our given number pattern. So what I will do now is rewrite this equation in standard form by moving the 216 to the right-hand side. I notice that all of the coefficients are multiples of 5, so I divide everywhere by 5. Now what you can also do is use the quadratic formula to solve for n. I normally prefer to use factorization, so n squared minus 3n minus 40 factorizes to n minus 8 times n plus 5. And you can see that I have two values of n is equal to 8 and n is equal to negative 5. But a term number cannot be a negative value and it cannot be a fraction or decimal. So we have established that term 8 is equal to 216. Therefore, 216 is a term in the sequence. Thank you for watching. Remember to show your support by hitting the like button and subscribing to Mathenatic.